बिस्मिल्लाहिर्रहमानिर्रहीम। अल्लाह के नाम से शुरू जो बहुत मेहरबान निहायत रहम वाला है। I welcome you all in the online lab of power system protection. Hope you all are fine and having good health. We start the session with some verses of Holy Quran, and later then we continue the session with today's topic, which is on IEEE 3 bus standard system, in which two generators, generator 1 and generator 3. Instead of that, you can set it as generator 2 and having the same range 250 megawatt, 250 megawatt, and we're going to simulate this model on ETAP, electrical transient analysis program of the software, and in which the three buses, bus number 1, bus number 2, and bus number 3 are connected together in the synchronization way, in the balanced load way, and particularly the impedances of Z1, Z3, Z4 also connected in this system, and the bus have an overall network have 100 kV of high voltage network. Further, the lump load of 1 having value 471.699 MVA that is connected at this site. So we are going to design or simulate the model on ETAP software, in which you will see the further steps. Uh, I already installed a software of ETAP 19 version, and I also share with you guys that how we can install particular software. So moving towards design and create a new project, the file name should be IEEE 3 bus system. Furthermore, you have to select metric 50 hertz and okay. Then moving towards the next step. So this is the existing project. I already working on this file name, and then username would be Lil Fun. Then full name IEEE 3 bus system. Email address particularly SLD, single line diagram or drawing. You can say this thing, and then okay. Then the file would be created after some of seconds. So it will take a long time. It will take long time to maintain and load all the kind of directory. It's my first attempt to make and install the software simulation in my PC. So it's difficult to make the kind of things. So now we are moving towards to select the particular generators from the options. So further we are selecting the particular generators, and where are the generators. First we have to find and select these things, generator 1, and further generator of MV rating would be placed there. So after that the lump load, hopefully this would be the lump load connected here, and then buses we need to insert at this level. Further control V, control C and control V at this level, and at this level. So this one would be control R, and this one would be control R. Generator have to be connected. If you want to connect and take the branch from generator, so it will be created from this side. So you have to move or rotate the generator, control R, control R. That means now can you can take the particularly here. Here is going to place the things this level. Okay, extend the kind of things. Then need to connect further, rotate, control R like this. Select to connect this one, and also extend the bus bar like this one, control R like this, and further extend the bus bar and connect the lump load to the bus bar. So particularly we have to make a joint, that how to connect a bus bar towards from this side to this side. So we need then impedance of the transmission line, and where is the impedance, there you go. We can place at this level, we can control C and control V and control V. Place at this level, place at this level, and also place in between the line, control R like this one, and this one, and to this one, to this one, this one to this one, and from where you, this one to this one again. So we complete the model which I shared with you guys. As you can see, this first indication can be placed from this side, from this side. Hopefully all things are fine, but we have to also see the things like this is the complete model which IEEE three bus system in these two generators, and one lug load is connected here, and three buses out there, three impedances of transmission line, and in between the joints of lines that would be the secondary distribution lines and connected lines, which is represented by the impedance of Z1, Z2, Z4, and particularly lump load and two generators. So I designed the particular three bus system of IEEE. So moving towards to rename and provide the data, particularly which is the generator 250 and 250 megawatt, 250 megawatt. So by double click the option, you need to place it at first have to select the swing and provide the rating at the rating option. Here you need to place the generator megawatt, that is 250 kV, I think 10 kV. So we need to confirm 100 kV, sorry. So 100 kV, and Sunday nominal, and all the things are fine. I think here more options you can see the capabilities of particular generator, synchronous generator that you need to connect, impedance model. You can set the percentage impedance, all the aspect related to the generator's grounding, inertia between the prime mover, coupling, generator. These inertial aspect of factors you can place at this level. Exciter, governor, PSS, and comment if you need to write some kind of comment at this option portion. Remarks related to the single line reference and manufacturer name, and single line diagram IEEE you can place in your system. Reference mm, one, name, read, and purchase date. That would be 18 May 2021. 18 May. So 18 May. Numeric number field would be 1, and particular are O and M aspects, time domain aspects, fuel cost, and the cost analysis can be fulfilled at this level, and the graph between the cost and output in megawatt would be adjusted in generator option. Further reliability aspects related to lambda mu you can place at this level. All things we are not aware of this thing, but I need to tell you all the related aspect which is mentioned in this software. So after that we provide the data, it would be okay. And after that, uh, the most important and beautiful aspect of this software is that if you place the KV rating in one of the component, the whole design would be except 100 kV, 100 kV, 100 kV as a operating level. So this is the beauty of 19th version of ETAP. Now moving towards place the value of second generator, that is 250 megawatt. I double click this generator 2 rename as generator 2 and swing. First you have to select ID already exists. Okay, so generator 2 instead of that generator 2 static can accept or not. Yes, it can accept. So we need to place the rating in megawatt. That would be 50 megawatt. KV already placed their MVA. It is not necessary to mention there. And after that, when you place a 250 by click somewhere else, all the relevant data would be adjusted by only placing the value of 250 megawatt. All the aspect parameter would be select automatically. This is the beauty of the software in sophisticated way. After that, we need to okay that generator to rating, and then we moving towards the value and place the value that is 100 megawatt kVA rating, that is bus bar value, that is kV rating 100 kV. And related regarding the buses are having the A, B, C. These are the lines of phases on which the transportation of electricity going through from line A, line B, line C. These are the phases, and these are the phase to phase of A, B, A to B, B to C, C to A, particularly kind of things. Load are the categorization of this thing. Motor, generator, rating, arc flash analysis can be placed out there. Detection aspect would be also be out there. Arc rating remarks you can place at this level, and SLD, 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 and reliability kind of aspect can be also be placed there, and harmonic analysis can also be found in this aspect. So after that scenario, we can select that OK. Particularly after placing the kind of voltage of this bus, we again have to select this bus and place 100 kV and OK. Similarly, coming towards this bus and place 100 kV and OK. After that, we need to provide the data of lump load. That would be 472 MVA. Mm, 472 MVA. Again, I repeat you guys for that. If you place elsewhere, select particular way, all the aspect can be select automatically, that megawatt rating, MVR rating, percentage power factor aspect, and ampere rating of maximum capability that can be flow by this bus bar, which we for suction load that we need to select, that we need to use. After that, by placing the kV rating, megawatt rating, we need to select OK. And then now it is the last part. All the related regarding matters we need to place from this aspect. So what will be the value of impedance? So we need to again moving towards the table in which highlighted, you can see 100 kV, 250, all the kind of relevant things we already select this thing, and related regarding things we already plays out there. Lump load we already select this way, and the generator one, generator two data already provided there, but the remaining things are impedance. That is from impedance 1 to 2, which we need to place the rating in kV, and resistance, admittance, susceptance kind of things we need to place there. So moving towards the further ratings of impedance, which is we need to place also there. So double click by impedance, we need to select the ID that would be from 1 to 2, and the impedance rating would be at this level. So we need to place the kV rating, which is the 100 kV. Select can be, and it is not necessary to select all the kind of thing, ampere rating, MVA rating. So the value of resistance would be R, it would be 2, 4 and 0. So we need to place 2, 4, 4 and 0 is an uncertain. So percentage base kV would be 100. You need to again place there, and other things are reliability aspects and remarks, comments, all things you need to place out there. Reference SLD and Adil, and then comments if you have any kind of comment in this data, and then OK. Furthermore, all the related things also be placed there, that is in between Z3 again from 1, 3 and 0, 1, 3 and 0, 1, 3 and 0, and then base KVA would be 100. Okay. Then also moving toward the Z1, need to provide the data aspect of 100, and what would be the data for Z3, that would be 1.25 and 2.5. 1.25 and 2.5, 2.5 and then 0 is same and certain, and the base rating of KV would be 100 also. And then we need to place OK. I think the remaining one thing can be left here, that would be the rating of 100 kV. All things are clear now. So if you have any kind of question regarding the regarding in this model, so feel free to ask. And further, if you see the recorded aspect and have query, you can discuss with me in email address adilkhanpakistan@gmail.com. I will explain you guys again the kind of data which you need to ask. So we moving towards the aspect related to the load flow. So this is a simple model, and now we have to find its load flow analysis. So this is the edited mod, and this is the edited mod for the model that we need to draw for this purpose. So now moving towards the load flow analysis, particularly click the button of load flow analysis, and the tool would be moving towards in this aspect, the load flow analysis. So run that particular load flow analysis, and we need to again rename the file, that would be IEEE bus system, and then OK. Let create the directory of load flow analysis of this IEEE bus system that we need to draw. So uh, here there is no kind of error till now, because all the related regarding aspect I already mentioned here, and because of this reason there is no kind of error would produce in this site. So this is the exercise which, if you follow the kind of the steps that I discuss with you guys, so there is no kind of error would be formed. Otherwise, in log message in this site, there are many kind of error would be formed in the form of 4 to 5 errors, and you need to resolve the kind of errors and simplify the particular things, and then things would be happening. Okay, these are the things which I need to explain you guys, that generator 1 produce electricity and provide to the bus 1 also share the particular kind of load via impedance Z12 to the lump load. Same as thing that generator to produce electricity, the rating 250 megawatt providing to the same this bus, and this bus also synchronized with this generator to the bus. Particularly this bus also served the load of lump load 1 by impedance Z1. So particularly these are the particular real and imaginary values which tells us the resistance and resistance and reactance, particularly what is going on at this bus level. So we are more interested to find the bus level of resistance and reactance, and the combination of these two things are the impedance of this bus. So this is working 100% on the load, and particularly after that losses, line losses in particular respect of these things, the 92.65% of electricity can be get from the side, and the impedance would also reduce the percentage of working of electricity at this level. So we are too much concerned with this impedance rating and also related with this impedance rating. This is a particular impedance rating from the generator, and this is the impedance rating of bus 4. This is bus 1, 3 and bus 2. So this is the way that how to utilize the kind of things. Now we're moving towards the all the kind of things. This is the auto run auto off of load flow analysis. So we all know this thing that this is the running aspect of load flow analysis. This is the running condition, enable and disable, enable and disable. So this is the running kind of things of load flow analysis, particularly of the load flow analysis. Remember this thing is 92.65%. So if we change the value of resistance, that would be from 5 instead of 4. So what will be the impact that would be happen in the percentage value? So it will also be cost to reduce. This is the thing which I tell you guys. If you increase the impedance value, which is too much high as compared to impedance 3 and impedance 1, so it will also cause to reduce the efficiency and percentage of transportation of electricity, as in terms of losses, in terms of electricity utilization of losses in transmission line. Particularly, it will reduce the percentage of working in this lump load. So this is the artificially created increasing of resistance in the transmission line, which I tell you guys to produce electricity at this level. Furthermore, this one is the run of the load flow analysis, on which the particularly this would be working. And then these are the alert views. If you have the kind of alerts that would be happened there, what kind of alerts would be happened there. So zone, if you need to filter out the zone, particularly this would be the zone, this would be also the zone, and this would also be the zone if you categorize the things in aspect of zone. Zone means particularly generation side is also a load. The categorization of three bus, three incoming, three things in which the outgoing incoming lines, one is incoming and two are the outgoing lines in this bus, similarly in this one and similarly in this one. And this is are the zone 1, zone 2, zone 3, zone 4, zone 5, zone 6, and particularly individual aspect can also be counted as zone. So 7 to 8 zones can be considered in this level, which you can also be select. So area, region, all the things can be select out there, and you can also be eliminate the kind of things if you're not going to find the alert. Okay, this is one important thing that you the report as a which you need for the particular aspect. You can also be create a report for this, which can be also created in the form of viewer, PDF, MS Word, all other kind of MS Excel. You need to generate of IEEE bus system. This can also be created. Input you can also be provided the kind of things, and results of the report and summary, the kind of thing can be created there. So we are interested in PDF form of this report. So we need to create this thing, the report, and report hopefully be created after this option. So is it creating or not? It would have to be created, but why it is not generating the report? So I think we need to wait for this. Why the report is not generating there? So we're moving toward the next aspect, which are the load flow analyzer. So option, that is the load flow analyzer, which can tell us about the file regarding load flow analyzer and the kind of things which we need to generate, like a report can be generating the data in this table. So this is the analyzer which can create the load flow analysis, particularly the aspect and the study IDs of particular equipment that we use for this model, and IEEE river system. All the things are generating and the data can be produced on the side of table. So this is the analyzer which can tell us the data. Now moving towards the load analyzer, this can also be detected in a loop condition. Okay. Moving towards the next aspect, that is the display option, in which all the kind of relevant data parameters you can see in the aspects and how it can be arranged. So you can see by checking all the parameter aspects, but it's a warning. If you select all the parameters, then multiple aspect can also be created and it will cause to complicate your model. Remember this thing. So if you okay the particular option, then what will be happen in this model after okay this option? So please carefully see this thing. So the model would also be going to complicate it. This is the magnitude angle of the bus, voltage angle. Particularly, you can see at this level, things can be happened, and this would be this is the percentage voltage variation. Even also, this is the phase angle in voltage phase angle in this aspect, and also in this aspect. So there are many other options and many other parameters you can also be highlighted by this option in ETA. Now moving towards the unit, what kind of unit you need to see in this model? So these are the kilowatt and kVAR units that we need to highlight in this model. And I think all things are clear. So if you need to change the unit and want to see the unit in the form of simple way without their units, so the rating of kilowatt kVAR cannot be showing there. But if you need to show the units, then kilowatt and kVAR entity can be shown in this aspect. So the combination of kilowatt and kVAR is called its apparent power rating, that is kVA, which is showing the combination of these two things. After solving the Pythagoras theorem, you can see the combination of real power and apparent power would be form kVA rating. Means that both entity at the same time, same combination can represent the apparent rating. Same apparent rating, and same apparent rating in this case. And similarly for this generator also. So we're moving toward the aspect that is the kVA rating. So all the things would be shown in kVA, and KVA, and what is the kVA? kVA is the apparent rating. So again, I highlighted for you guys bus 1, but it's not showing here. It's show. So this is the kVA rating of this bus. This is the kVA rating is the outgoing supply from this bus, and this is the again outgoing supply rating of your kVA to the lump load. Again the kVA rating for this bus of the line, and this is the kVA rating of the generator. So you can see we can select the particular kVA rating. Similarly, the ampere rating, that how much ampere can flow from this particular line as a bus bar of the line of, sorry, the transmission line, and as a bus bar of the generator right to the bus bar, that particular ampere you can find from this model. And how much ampere provide from this generator to the bus bar, the ampere can also be found this way, and particular ampere can flow out to the lump load one, the ampere can also be showing out this way. So if you're not in the interest to see the ampere rating, so you can also be changed by ampere to kVA ampere rating. So kVA and ampere rating can also be appear in particular aspects. So again we move toward this thing. So entity can be highlighted by this way, that what is the kVA rating, what is the ampere rating can also be showing it here. But the thing is that the design would also be looks like very complicated. So things can be understand if you gradually increase the complexity in your model in gradual way. So after that, if you're not interested to see the ampere and kVA rating, so again you can click things that kilowatt rating would be showing that what is the real power from this side, this one, and individual lines, buses, generators, and lump loads particularly can be seen by this option. So after the kilowatt, what will be the kVR rating? kVR are the losses, the particularly how much kVR losses are produced at the generator level, and the load side of that bus particularly, and all the particular aspect can be seen out there. After kVR, you can see the kilowatt and kVA, that is be seen in the starting aspect. You can see the kVA and kVR, losses and real power. And the combination of these two things would become the apparent power. So now moving towards the percentage voltage regulation, that how can we find there. So if you particularly select the kV rating, that how much kV rating would be formed can we appear out there. And again, if you need to find what is the voltage rating can also be seen out there. And again, if you click the particular rate, so percentage voltage regulation can also be seen out there. So this is the operating voltage units in which the entity can be seen by this thing. Furthermore, the load terminal voltage and other things also be out there available there. So this is all about today's lab of IEEE standard bus system, and in which we simulate the things. If you can see the thing in the model form, the things can be looks like very simple, but it is not very simple if you not follow my described steps. If you not follow my described step, then this simulation would not be run. Remember this thing. So in the last thing which I tell you guys, that if you again moving towards the simple model, so what would you have to done? You need to select edit mode. You again moving towards this aspect, and all things which you working on the particular parameters, you move to a particular, all kind can be moving, and the simple model can be appeared this side. So this is all about today's lab. So we need to end today's lab. So inshallah we again meet to discuss some other model of IEEE buses. So we end today's session. Allah Hafiz.